Let's do checkpoint 6.15. They want us to evaluate the line integral, the integral over c of x squared plus z, yz, ds, where c is a line parameterized by r of t is equal to 2t, comma 5t, comma negative t from 0 to 10. And then they want us to reparameterize c with a different parameterization, s of t, that's 4t, comma 10t, comma negative 2t from 0 to 5. Recalculate the line integral and notice that the change of parameterization has no effect. All right, so let's establish some information here. We have a scalar function. We'll denote that by little f of x, y, z, and that's equal to x squared plus y, z. We have two parameterizations, one r of t, and that's equal to 2t, comma 5t, comma negative t. And this parameterization goes from 0 to 10. And then we have another parameterization called s, and that is equal to 4t, 10t, negative 2t, and this one goes from 0 to 5. Now they want us to compute the line integral of each of these things for the different values of c. For the first one, we want the line integral, and we want to evaluate this at r of t, and the ds becomes the magnitude of r prime of t dt, and we're going to take this from 0 to 10. Okay, which means we need r prime, which is 2, comma 5, comma negative 1, and we need the magnitude of r prime, which is going to be the square root of 2 squared plus 5 squared plus 1 squared. Okay, this is an integral from 0 to 10. F is x squared plus yz, so this will give us 2t quantity squared plus y is equal to 5t, and z is equal to negative t. So that's the function evaluated at r of t, and then we want the magnitude of r prime, which is 25 plus 4 is 29 plus 1 is 30, square root of 13. So this is our integral, our first one, and this is going to be 4t squared minus 5t squared, square root of 30, dt, and we add them, we'll get negative 1, and square root of 30 is a constant. Integral of t squared dt, which is t cubed. This is from 0 to 10. And this is going to be negative 30 times 1/3 t cubed from 0 to 10. Oops, this is a square root. And we'll put 10 in there. We're going to get negative 1,000 root 30 over 3. Okay. So that's our first integral, and we want to compare that with our second integral, which should be hopefully the same. It looks like we will also need the derivative, which in this case is going to be 4, comma 10, comma negative 2, and the magnitude of the derivative, this is s, is equal to negative, well, not negative, but 4 squared plus 10 squared plus 2 squared, and that, well, we'll work that out in a minute. We're going to integrate this integral from 0 to 5 this time, and our function is x squared, that's 4t squared, plus y, which is 10t, times z, negative 2t. And this is where we figure out the square root of 100 plus 16 plus 4, so that's 120 dt. We can combine this. This is 16 minus 12. 16 minus 12 is, oh, I'm sorry, this is 20. 16 minus 20, that's negative 4. So we'll throw a negative 4 root 120 out here. And we will integrate from 0 to 5 of just t squared because all the constants were taken out, dt. This, I believe, is we can take out 4. We take out a 4, we should get 30. And the 4 outside of the square root is 2, so that's negative 8 root 30. And this is 1/3 t cubed from 0 to 5. And this would be negative 8/3 root 30. And 5 times 5 is 25 times 5 is 125. So 125 times 8 turns out to be 1,000. And that matches with our previous one, so it looks like it's all good. Different parameterization of the same curve, in this case it's a line, going from different limits will still give you the same result, even though if you had different parameterizations. Okay, I hope that helps.